Hello everyone, and welcome to our developer community webinar called InterSystems IRIS AI Hub, Goals, Games and Goodies. First of all, thank you for joining us today. My name is Irène Mykhailova. I am a moderator of the InterSystems developer community, and I'll be your host for this session. So we have quite a lot planned for today. And for the community-driven webinar, we've deliberately put together a mix of product overviews, technical content, demos, and real-world experiences. So let me quickly walk you through what you can expect. So we'll start with the introduction to InterSystems IRIS AI Hub, what it is, what we're trying to achieve with it, and where it fits when you're building AI-powered applications and agentic workflows. Then we'll move pretty quickly from the what and why into the how. We'll have a technical deep dive where you'll get to see AI Hub in action and understand more about how you can actually work with it as a developer. And then we have a couple of demos prepared for you. One of them is SQL Golf, and another is Iris Moose. Won't give away too much about those now, but you'll see what the games part of Goals, Games, and Goodies means soon enough. But we also wanted this webinar to go beyond demos. We think that one of the most useful things when looking at a new technology is hearing what happens when people actually start using it. And I'm particularly happy that today we're not only hearing from InterSystems people, we also have Gianni Muzzin from Zorgi and Heloisa Paiva from Zarmik, who join us to bring an external perspective and share their experience. Throughout the webinar, please feel free to put your questions into the chat. So throughout this webinar, please feel free to put your questions into the chat. We see them all. And afterwards, we'll have a dedicated Q&A session. As I said, you don't need to wait till the end to submit them. Just post them as we go, and we'll go through them, as many of them as possible at the end. Having said that, don't leave immediately after the Q&A, because we have two interesting things coming afterwards. First of all, we'll tell you about the Community Bounty Program, which is called Idea to Application. So if you see today something interesting, or it gives you the idea what you can do with AI Hub, you'll definitely want to hear about our bounty program. And afterwards, we're going to finish with the fun Kahoot quiz. So please pay attention during the webinar, because at the end, we'll see how much you remember. And of course, there will be prizes. So that's the plan for today for our webinar. And with that, let's get started. For our first part, I'll hand it over to Benjamin Debo, who is a project manager in the data platforms team, and he will give us an overview of IRIS AI Hub. So Benjamin, I give the floor to you.
All right, thank you, Irène. Thanks for that intro, and very much looking forward to hear, well, to not just see the games that Louis and Lynn implemented, but also very much what Gianni and Heloisa are going to show, because this has been something that we first announced at our global events back at the end of April, but then started an early access program right after, and it's been the most successful of all the early access programs we've ever had. We've got over 100 individuals that have signed up, so very exciting to see all of the things that this wonderful group is coming up with. All right, so let me talk a little more about what this product actually is. What is the InterSystems IRIS AI Hub? Some of you may have played with it already and know it very well, but I'll just start from the start. What is it that makes one AI project successful and another not successful, or less successful, I should say? You hear all these kinds of dreadful statistics about AI projects failing to get from the pilot to the production stage. What we're hearing most from you, also already before we had the AI Hub, of course, is that it's not just a technology problem. It's not making sure that I can run 20,000 concurrent users on this agentic system, or it's not that we're unable to write this up in code. It takes us too many lines of code. It's really about the context, making sure that your AI application has access to your enterprise data, has access to your enterprise tools, has access to your enterprise governance, and really blends right in. That it's not something that sits on an island at the conceptual or technical level. So that was sort of our starting point for developing the InterSystems IRIS AI Hub, to help our customers build your AI projects in the right context from the get-go. And you could argue that we actually got started with that already quite a few years ago with InterSystems IRIS Vector Search. People weren't talking as much about agents at the time. It was more all about generative AI. So in 2022, 2023, we started working on vector search, early access program, also a very nice one with some of you probably joining that one too in 2023. And then with 2024.1, InterSystems IRIS Vector Search became generally available, offering you fast and easy Gen AI with contextual data. So what we did was we built it right into the core of InterSystems IRIS, such that you didn't need a standalone vector database to cover to make sure that your generative AI applications had access to contextual data and were able to do similarity searches right where the data is. We built it right into IRIS, so fully integrated with the multi-model data engine. So most people are using it in a relational way, but you can easily wire it up with your document context, or document contents, etc. Offering your AI and agents quick access to contextual data. And you don't have to worry about synchronization schedules, nightly batches, storage waste from having multiple copies of the data, etc., etc. So that was the vector search capability in 2024. What we're now doing in 2026 is we're turning our data platform into a true data and AI platform with the launch of InterSystems IRIS AI Hub. With the Hub, we're offering customers a fast and easy way to build native agents with highly contextualized access to data, leveraging vector search in the process, but also to tools, to workflows, to governance. And we built it deep into the IRIS core, which means that it also inherits the scalable compute, the rock-solid security, and the flexible workflow services that you already know and use inside of our platform. So that's what what our goal is with the AI Hub. So let me talk just a little bit more about the key capabilities of the Hub. So first and foremost, it comes with a framework that helps you build native agents on IRIS. That means that as a developer who was previously building enterprise applications and business workflows, you can now, without engaging any third-party technology, without writing new code artifacts, new DevOps practices, new technology tiers, you can augment your application or your workflow with an agent. That is a very powerful concept, and we've got some really nice reviews from early adopters. Some saying that it felt supernatural to build something supernatural at the same time because of the deep integration with how you just work with ObjectScript or embedded Python in IRIS. Second, we offer native support for the Model Context Protocol. In case you hadn't heard that acronym before, MCP is the leading standard for interactions between AI and regular business logic or data. For developers who build native agents in IRIS, that means that your native agents sitting on IRIS can tap into anything published as an MCP server outside. So that fits in our interoperability theme. Examples of that many people are using are the Jira MCP servers, Workday MCP servers, SharePoint, whatever, you name it. We also support inbound MCP in case we, with IRIS, act as the MCP server, offering both the STDIO local and the Streamable HTTP transport layers. And that's really meant to be a declarative experience that doesn't require you to write any new code because you were already done developing your business logic. We're already done managing your data. So it's just a couple of clicks in a simple user interface to expose those capabilities to the MCP protocol, which means that you can get at them using agents that you would build outside of Iris. For example, a simple Claude desktop application, or the Open Web UI. Some of these straightforward conversational interfaces can interact directly with any MCP exposed capability. And then finally, we're not developing this in a vacuum, in a new tool environment where you need to build your security from the ground up again. It works under the same user and role definitions, the same role-based access control, security, auditing. It's integrated with our human workflow engine in Interop. So it's very easy to include human oversight in your agentic workflows and ensure that approvals are obtained appropriately. That goes a lot beyond when Claude asks you for an elicitation. Oh, can I execute this tool? Because in a real enterprise workflow, it might not be somebody sitting in front of Claude Desktop, but the person who needs to approve, he might be at the other end of the country, or he might be on holiday, and the manager that needs to approve it might be in a different location. So that human workflow part is something that we've supported all along, and it fits right into your agentic workflows. So it's important to tie back to the interoperability theme. InterSystems, we didn't pick our name just for fun. We've always been kind of at the center of systems. We've always played a very important role in connecting systems, services, and data in many mission-critical environments. And today, we're connecting to systems, services, data, and AI in that same mix. So before it's about time to pass on to some of our other speakers, I wanted to just show you how this fits in the broader context of some of the other AI initiatives and product capabilities that we're working on. I'll start from the bottom right. So this is Iris Agentic Dev is a tool that actually I think quite a few of you have already tried. Iris is built for builders, and many of those builders, they build code, they develop applications, they develop integrations. The Iris Agentic Dev is a set of tools that integrate well with VS Code, with Cloud Code, and other IDE and CLI development environments, and give you streamlined access to the relevant Iris documentation, class reference, including for your own code, which may not have public documentation. It has tools for unit test generation, for just generally approaching problems, and much, much more. So it's a very powerful thing to increase the developer productivity when you're building applications on Iris. Now, if what you're doing is kind of less code-centric, but you're building integrations, interoperability productions, data transformations, we're launching an early access program shortly for the Agentic Integration Builder, which is a co-pilot for developing those integrations that blends right in with our interoperability UI and helps you build those integrations based on user prompts or specifications that you would upload. Now, for the runtime phase, we offer a complete set of integrated AI assistants. You may have heard about the Data Studio AI assistant that we launched just a few weeks ago, the Supply Chain Orchestrator, which helps with decision intelligence in our supply chain offering. We've got a health share AI assistant. We've got a whole product called IntelliCare that is full of agentic AI. So those are all solutions where we're focused on end users, helping them do their regular business jobs more effectively. And then to come full circle again, all of those systems can be built with the InterSystems IRIS AI Hub using native technology to offer you governed agent runtimes on Iris. So that's how these things all fit together. Just before I pass it on, why did we build the IRIS AI Hub? We want to make sure that you can develop your applications in context and solve that context issue that I called out right at the beginning. We want to make sure that you've got immediate access to the most relevant tools at the right time, to the most relevant data at the right time. We want to make sure that this also all fits in your existing security context, making sure that you can govern access to and from agents. So making sure that you can specify policies of who gets access to which agent, as well as which agent can get access to which resources. And then finally, that approval thing that I mentioned earlier, making sure that you can easily blend agents and humans in a single workflow. That too is a very important aspect of the context that we're trying to provide with this data and AI platform, thanks to the InterSystems IRIS AI Hub. All right, with that, I think I'm done with the brief overview of what the AI Hub is, and I'm very excited to see the next presenters walk you through some concrete examples of what we've of how you would build something, and then what some of our customers have built with the AI Hub already.
Oh, well, thank you very much, Benjamin. So now that we have a good understanding of what AI Hub is and what we're trying to achieve with it, let's get into the actual technical side and see how it actually works. And for that, I'm inviting Gabriel in from the developer relations team. He's been working closely with AI Hub, particularly from a developer point of view, from developer perspective. So Gabriel, the floor is yours.
Okay, thank you very much. So I'm going to walk through a basic project that can be built with AI Hub. So I'm going to build a kind of basic agent and an MCP server just to show how AI Hub works. So this is our IRIS instance. It's an AI Hub instance. I'll move my cursor. So, and I have some data preloaded, and I'm going to see how an agent can, how we can build a very simple agent to access that data. So I have a bunch of classes. The first thing I'm going to do, the first thing I'm going to do is show that the data is there. So we have some tables. The kind of use case here is a agent that helps manage stock in a warehouse. So we have a bunch of products, and we are going to build an agent that can manage some of this products for us, so we can just talk to an agent rather than do things ourselves, and then make that into an MCP server. So it's a pretty simple project, but it will show how to build agents and MCP servers. So the first thing to do is to create some tools. So we want tools that can access the data. These are things that agents can use, functions that agents can use to access the data. And to do that, it's very simple. We build a normal class that is a normal Iris class that extends %AI.tool. And this is the new system class for AI Hub tools. And then all the query components and methods and class methods in this tool set can then in this class then become agent tools that an agent can autonomously use. So we can create a query just against our data set, we get the products, return them, and the agent will just be able to query that and get all the products. So you might be wondering why we're not giving just a tool that runs any SQL query. We could absolutely build that, but that's not really within a safe governance model. We're more interested in controlling what an agent can access and give it a specific use case. And that also allows us to use kind of smaller models. So we're building a bunch of tools. So these are just query components, and an agent can create these. It can activate these and return the results. So that's a really easy way to access the database. But we could also include some more involved models. So maybe we want to do some things that write data to the database. So we can do this with ObjectScript, or we could use embedded Python here if we wanted to use a language equals Python tab. But here we're just going to build a simple function in ObjectScript that logs movement in stock and product stock tables. So basically, if something broke in the warehouse, you could log that in the database. And this description will be visible to the agent. So we provide the same way you would as a normal method in a class. You provide a description, and then the agent can see it, and it can also see the parameters and the expected data types for the parameters. So it kind of can infer from this how it should be used. You can make the descriptions more or less descriptive depending on what you want. But we're just going to open a product by ID and then reduce the quantity and save it, and do the same thing with just logging the movement to the database. So these are quite simple object script functions, but it's just writing object script, so we can make them as complicated as we want. And similarly, we will write one more class method here, where we're going to access a interoperability production, so the agent can directly call our running productions. This is order products, so we have a production that will just automatically order a product from the right supplier, so we can create a business service and then call that business service. So I'll just let that keep running, and then we'll get on to giving this to an agent. So similarly, creating an agent class is equally simple. Next thing we're going to do is put it in a tool set. So a tool set is a collection of tools, and it can also combine tools with policies. So policies are things that run before or after a tool is called. So here we're defining a toolset by extending %AI.toolset, and we're creating a definition of that toolset in XML. And the XML is we add in other components into it. So we give the tool a name, a description, and then the policies, which can either be authorization policies or audit policies or discovery policies, but essentially these policies run before or after a tool is called. So before can reject a tool call based on certain logic, so you can write custom ones. So for example, does the user have the right role for this policy? Or it can also you can also have audit policies where every time a tool gets called, you log it in a certain way. So here we're just going to use a simple, two simple policies. They're console authorization, so it just asks the user at the shell whether it can make this call, and console audit, so it just prints the tool call. So these are pre-made classes, but you can make your own that are more complicated, or you might log it to a database, you might log it to a global, or they're just written in object script, so you can create whatever logic you want. And then you include whatever tools you want. So you can include external MCP servers here, but you can also just include a tool class. You can also add inline tools and queries, so tools defined in the same class, or you can filter tools by, say, the name of the tool from within the tool class. So this is a really powerful way to kind of organize how your tools are distributed. So maybe you have agents that need slightly different sets of tools, and you can filter them and provide only certain tools to certain agents. So that's our tool set class, and we've given it we've given it policies, so we can kind of see what the agent is doing here. So we're saving that and compiling that. And then finally, we're creating an agent class where this is where we tell the agent what to do and where we give it the tool. So this just extends %AI.agent, another system class, and we have to define a few things. We define what large language model we're going to use. So I'm going to use the Bedrock ID for Claude Sonnet 4.6, and then we define the tools that it can access. So we're going to give it the tool set that we've just created, So this is in the parameter toolsets. And we could do a whole list of tools and toolsets here, and they don't need to be toolset classes. We just do comma-separated lists. And then we do a system prompt. This is Xdata instructions. This is just markdown instructions. You might want more complicated instructions, so like always reply and this structure response. But here we're just using a very simple system prompt. And then finally, we're going to define a %on_init class method, which runs every time you initialize an agent, which you need to do when you create it. We'll get to that in a second. But this custom version will will create a provider, which is our large language model provider. So that's like OpenAI or Anthropic. We set the provider and then can use that provider to call the large language model. So we'll see that in just a second. So here I'm getting the key from a environmental variable, but there's also a configuration store where you can kind of store things securely and give roles like roles-based access controls over who has controls to what. And then we just create the provider with that key and the region for Bedrock. And the final thing we're going to do here is to create a simple chat loop function to make it easier to demo, but you can make this more complicated. So this is going to just handle our input output, so we don't have to constantly write the same thing. So we get a user input and we chat to it and then render the response as markdown. So with all that in place, we will in a second get to how to actually use it. So firstly, I'm running it in a Docker container, so I'm going to start a IRIS an IRIS shell, and then so then we can enter the right namespace, and then we instantiate the agent. So set agent equals warehouse.ai.agent. And so we create a new agent. We then initialize the agent. So this adds the provider to the agent, and we so that calls our custom initialization method, and so at that point it might error. So you can use that status there to check the error, and then finally we can create a session. So a session is a kind of individual chat with the agent. So these are persistent, so you can save a session and resume it later. And then we can just do set response equals agent.chat, and then provide the session, and we give it a system prompt. So how about what products are in my warehouse? And that agent can then use the tools that we've just defined to create, to then search. So this is the policy that's asking for authorization. Can it use the get products tool? Yes, it can. So it then runs get products, and you get a brief intro to the results. So we can now use the chat loop function or method that we defined above. and go into a bit more detail and show some more examples. Oh no, so sorry. I'm using this built-in Markdown rendering to read the response, the content of the response object, so you can see what the agent says. And here it formats them all. It tells you which ones are low in stock. It didn't need to do that, but it just received all the information and has told us what's in stock. So then we can use, so it says, would you like me to check which products need reordering? So we can use the basic chat loop function that we've defined to continue the conversation. And let's say, yes, check which products need reordering, which is a separate query here. So do agent.chatloop. And we provide that session, so we continue chatting with the same one. Yes, please check. And it calls the second function that we've done. And yeah. So yeah, these are coming. These authorization requests and the printing out the tool call is coming from the custom policies that we've defined above. So we can ask one more message. I only have budget for, say, one product to reorder. Which one should I do? Should I order? And the agent will work out from this that the intent is, use the sales by product function to check which products are selling best, and based on this, it will give a recommendation on which products to reorder. And then we can read that recommendation, and we can say, yes, reorder this product. So it's given this is how many is above and below the reorder. So yes, please place an order for 20, and it sends an order request and orders the product, and it receives the response, order sent. So we can just check on our interoperability production here and see that the agent has, it should have sent the order, and we can see the message trace here. So we know that it did indeed send the order. So this is a nice example of the agent fully integrating with the existing kind of IRIS structure and other things. So the next thing we're going to do is just make an MCP server out of this, out of the same tool sets or the same tools. So we've seen it. So MCP, you can add tools to existing agents rather than create new agents with custom tools. So for example, I'm going to add an MCP server to my existing Claude Code instance. So this is really easy to do with AI Hub. So you can just do, you can create a new class called mcp.class in this instance. And all it needs to do is extend from %ai.mcp.service. So let's do that. And then we can give it a specification parameter, and that's our tools. So here we're using the tools, not the tool sets, because the console authorization will break it. So we don't want to use that policy. So I'm just going to use the tools, but we could have different authorization policies in a tool set if we wanted. We just don't have access to the console from the MCP server. So the %mcp.service extends csp.rest. So we need to create a web app with this as a dispatch class. So we firstly create a web application. There's a separate MCP server menu. So we can go security roles applications, and there's this MCP servers menu, and we can create a new MCP server. We give it a name, so it's just like a web app. You give it a endpoint MCP/warehouse in this instance, and make sure it's in the right namespace, so the same namespace that the dispatch class is saved to. And we give it the MCP service class. And let's make it unauthenticated to make our life really easy. And we're also going to, in a second, give it all roles just to make sure we don't have any kind of roles-based issues. But this fits exactly into your existing kind of IRIS security environment, because you can use roles in exactly the same way as in existing web servers. So we've created our MCP application, and we've connected it to the tools. So the other thing we need to do is create a, just going to make sure I saved it. The next thing we need to do is to use this new binary, which is iris-mcp-service, which actually handles the connection from your existing agent, so whether it's Claude Code, whether it's Codex, whether it's GitHub Copilot, etc. That connects to this MCP server binary, which then connects to Iris. So this is the binary. I'll just run help to show some of the options. So there's various logging and telemetry available here. So you can monitor running MCP servers. The thing I'm going to highlight here is this config file, because you need to define how your MCP server is configured. So the main option is whether you're using standard input-output transport, STDIO, or HTTP, or one of the others. You could also define this in line, but I'm going to define it here. So this is config.toml. This is just a basic config file. And we need to give a few things here. We give the Iris connection info. So we give the connection a name. We give it the host, the port. So this is the super server port because it handles the connection to Iris. And then we give it the endpoints, which in this case is just the MCP warehouse application that we just created. And then we handle the kind of MCP side, so how our agent will use this MCP server. So we're going to use an HTTP MCP server because it's running inside a Docker container. Standard input-output is sort of used if you're running the MCP server on the same computer as your coding agent. Docker containers essentially count as different computers, so you need to use HTTP transport to access it. Yeah, so that is our config file. So we can then go back to the command line, and we can do Iris MCP server -c, and then give the config file, and then we can run it. Sorry, I pre-recorded this to make my life easier, but in a way it makes my life harder because I'm out of sync with it. So I'm very sorry about that. Yeah, so we're doing Iris MCP server config.toml, and then do run, and we can see that the MCP server is running, and we have a kind of running log of it. So this needs to be like permanently running in the background for our coding agent to connect to it. So the very last thing we need to do is we need to give the config for our coding agent, which in the case of Claude is a .mcp.json file. That's for a local MCP server, a kind of project-specific MCP server. If you want it to be available from everywhere, you can add it to the .claude.json in your homepage, in your home directory. But we're going to do a project-specific one here. It's in various places for various different coding agents, so you'll need to find the right one for the one you use, but I use Claude Code, so this is how I do it. And the only configuration we need is the type, that it's an HTTP MCP server, and the URL, so that's the IRIS instance /mcp/warehouse, which is the application we just defined. So then I can start up my Claude Code instance. So I'm just highlighting here that I had to map the port out of my Docker container just to make sure it's accessible. So that was in my Docker Compose, in the same way you would if you were running anything else on a port in your container. So I open my Claude Code, and I edited out the startup time, and it says we've got a new MCP server. It's found in .mcp.json. So I said, yes, please use it. And you can actually see in the bottom, it's then discovered 5 tools from this. So the logs know that something's connected, but I can ask my Claude Code what products are in my warehouse. And we can see Claude Code thinking, and it will say fetching product list. It's using this new MCP server, so it's working fine, and Claude should then be able to access our data from anywhere via this MCP server. So it's given me a very similar response to the same Claude model from an IRIS agent. So the final thing I'm going to do here is say we've had an incident in the warehouse, and a forklift has crashed into crashed into a shelf, and we've destroyed all of the dinner plates in our warehouse. And we'll see Claude Code, what Claude Code can do with that. So we say, smashed all dinner plates, there are none left, can you log it for me? And it can then, it reads this, it understands that it should set the quantity to 0, so it's calling that tool that we defined earlier, and that way we can use an agent to kind of access our data, and yeah. And we've used unauthenticated access here, which means that it runs as unknown user. But if we used authenticated access, it could actually tell us that this user logged this thing. So access is based on the like login that you give to the HTTP MCP server. So you can have your agent act as you and acknowledge that it's you. And yeah, there's it logged in our database. So that is the end of my demo, or my deep dive on how to build agents and MCP servers in IRIS AI Hub. So with that, I will pass back to Irene. Thank you all for watching.
Yeah, thank you very much, Gabriel. And now that we've seen how AI Hub works, we can Oh, sorry. We can go on and see the examples of what we can actually build with it. So let's hear from Lynn. She is a sales engineer at InterSystems, and she is going to show us how her submission for the recent Employee Programming Challenge, SQL Golf, for which she used AI Hub to add a playful note to the competition, how it works, and what she did with it. So, Lynn, the floor is yours. You're welcome.
Hello, my name is Lynn Wu. I'm a sales engineer at InterSystem. The story behind this demo actually started, as Irene was referring to, as an InterSystem employee coding challenge. See, we all do just fun things all day long at InterSystems. One of the challenge was code golf, which means solve the problem correctly using the fewest characters possible, just like golf. So it was a fun way to think about programming. And somewhere along the way, I thought, why not SQL golf? Writing SQL can sometimes be feeling like just extreme data wrangling. You need to figure out how to filter, how to group, how to join, how to twist, and turn the data until you finally get what you want. What if we can turn that into a game? And instead of just telling you whether you're right or wrong, give you this non-friendly red message, what if AI can actually coach you towards a better solution? It could be telling you how long your query is going to run. Is it going to be seconds or days? Is it going to crash? Things like that. So that's why I built SQL Golf and on IRIS AI Hub. Let me quickly show you how the game works. So on the left, we have a very simple data set that we're starting with. This is the table schema, and this is the challenge, and a preview of the underlying data. In this case, we are looking for stars whose brightness change significantly over time. In the middle is where you take your shots. You basically write a SQL query, still need to write that, and hit swing. And just like golf, getting the right answer isn't enough. The goal is to get there with the fewest characters possible. And at the top, we have the scorecard, which tracks your progress across 9 holes. For this challenge, the par is at 88. So actually getting the wrong answer is where things get more interesting, because that's where you can get the feedback, right? So instead of just saying it's wrong, the AI steps in as your coach and understands what you attempted and explain what's wrong and gives you a useful nudge without simply handing you the answer. And our coach's name is actually Jaden, and he is Gen Z. So he's constantly online, very technically savvy, sarcastic, and despite his attitude, he is actually very helpful. His roles are funny, but they are also designed to move you towards the right solution. So why don't us take a swing? Okay. Ooh. Jaden kind of knows exactly what I try to do, which is trying to cheat our way in. So that also tests out importantly. This game isn't about counting beans. It's actually validating that I have returned the right 57,099 stars. So apparently, I can do real SQL according to Jaden. So let's have another attempt. Okay. Let's see. Let's put in a little more effort. Oh no. So clearly I need another lesson. Let's see how many different ways I could disappoint my coach today. But notice what is happening, okay? That there is actually all the coaching to tell me that I gotta filter out those invalid observations. Oh, so there are like the traps that I need to be watching out for. So that is actually pretty helpful. Let's give it another try after all this encouragement, shall we? Okay, let's give it another swing. One more attempt. Let's see where we are at. Oh, and here we go. We got the correct. Oh, and I'm just loving all the comments that Jaden is making. Apparently he's retiring early. This is the era, for real, huh? So here we go. This is where I think the gamification gets really interesting. The feedback is not just contextual and instructive, like a traditional SQL query that would return you. It actually, AI allows a voice. So Jaden is sarcastic, and you may not really like him so much. But I could make the coach more encouraging. I could make the coach speak very concise, highly technical. It could come to you, like adapt to your style. So we're not just asking AI for an answer. We are using AI to create that experience that helps someone to learn and navigate a workflow. And by the way, everyone here is welcome to play the SQL Golf, right here. It's publicly hosted, so you can try yourself. And it is a limited edition, like it's a limited release. We're only keeping it alive for another couple of weeks, so play it while you can. We should take a little pause here because I think that there is something bigger than just maybe a silly SQL golf game here. That the same data and the intelligence underneath can support completely different user experience depending on what somebody needs. So it can be a game like what we are showing here with SQL Golf. It could be an immersive visualization. So imagine instead of looking at rows and columns of data, that you can explore where these stars are in relation to one another and discover the pattern yourself to explore yourself. Or if you are so analytical minded that you just want a quantitative dashboard that shows you the statistics, the trends, the distribution, the precise answers, you can get that too. So, tomorrow we can even think about a brand new, different experience because the underlying data and the intelligence are separate from the presentation layer. So we don't have to rebuild everything every time the experience change. So I think what I will see is that now we're in a new era. Instead of designing one interface for every user, we can start to think about delivering the right experience for the right user and potentially on the fly. So let me briefly show you what is underneath the game, underneath the hood. So what I really like about this architecture is that the IRIS AI Hub is integrated directly into IRIS. So AI is, as we know, it moves incredibly fast, and then we will want the freedom to experiment, to try new models, new agents, and new user experience without a lot of friction. So that layer needs to be agile. But underneath all that experimental experimentation, we want something that's actually stable. So that means like our enterprise data should have security, should have all this nice policy attached to it, as Gabriel have demoed, and with governance and core infrastructure. And that definitely cannot get lost every time when we are changing the AI landscape up there, right? So that's where the IRIS AI Hub comes in, right? Because IRIS is a battle-tested database platform with more than 40 years of engineering built into it. So it is meant for performance, reliability, security, and scale. And IRIS is also multimodal, which means now your operational data, document, vectors, spreadsheet, images, videos, and relational graphs can all live in one place. And all of that consists of the durable knowledge layer for the AI to act upon. So we can now move fast the AI layer on top without constantly rebuilding the foundation underneath it. So let's actually look into the code a little bit. It's very simple. So as Gabriel have shown you before, I am creating an AI provider and creating an agent and selecting a model. It's as simple as that. 1, 2, 3. Okay.
Your code is not showing.
Oh, sorry. Okay. Yeah. Great point. Thank you, Benjamin.
Great.
Yeah. Can you see the tab now?
Yeah.
Okay. So, yes. Okay. So here's the provider and the agent and the model. And I think that illustrates another architectural pattern that I think is important, that the LLMs are increasingly as commodities. So today I'm using Claude through the Bedrock, but I can swap models in and out depending on the use case. You know, I certainly don't need to throw the biggest frontier model at every problem. So if a smaller model can do the job effectively against my local knowledge layer, I can use that instead. So that can reduce cost and latency. And that's doing a little like anti-token maxing, if you will. The important thing is that changing the model doesn't mean that you should redesign the application. And that's what the IRIS AI Hub that enables you to do. Because we would also underneath need OLAF, need role-based access control, we need all the security and governance and traceability of AI operations, which is vital for building enterprise level like applications, right? So to me, this is going to be the architecture. Basically, the battle-tested data foundation, and with the flexible AI layer set on top, with an interchangeable language model and adaptable user experience. So over time, the models can change, the experience can change, but the secure governed data foundation, that's what stays the same. And so AI can move fast, but your data foundation doesn't have to. Thank you.
Okay, thank you very much, Lynn. It was very interesting. While you were talking, I ran a short poll asking people if they wanted to have Jaden as their coach, and apparently 100% of people who answered actually did. So, you did something really great. Anyway, we're going to stay with the games for a little longer, and our next example comes from Luis. He's another one of our sales engineers, and he has built another game. So rather than trying to explain what it is...
Hi everybody, my name is Ángel Pérez, sales engineers at InterSystems Iberia, and today I'm going to show you the workshop Irismus. And what is Iris Muz? Well, Iris Muz is a fully functional web application developed in React that uses InterSystems IRIS as backend. This backend is connected to an local LLM based on Llama using the AI Hub capabilities. Our main goal with this demo is to provide to our customers with a real example of the use of AI Hub and InterSystems IRIS. Why? Well, here in Spain, our customers usually are a public health service with a very limited access to the traditional commercial LLM like ChatGPT or Claude. So they have to use these local LLMs to work with generative AI. The problem with these local LLMs is that they are very limited. So the idea is, with InterSystems AI Hub, improve the behavior of this LLM and take advantage of the code that they have already developed in InterSystems IRIS for Health. So, for this project, we are going to grab one local LLM, Llama, as I said before, and provide all the necessary tools to play to this card game known as Muz. This Muz is a very traditional Spanish card game that everybody knows here in Spain. But in the case of this local LLM, he has no idea how to play to it. We can see here in the article of our community the answer that the local model gave to me when I asked about what is the Muz game. It's a totally nonsense. He has no idea about how to play this game. Well, I will try to summarize the rules of the Muz game because it's a bit complex. Well, the game is played by 4 players in 2 teams. We have one of the players, like the hand, that is the responsible to deal the cards. Each player receives 4 cards. After the Muz phase, the game starts with the Grande phase. In this phase, the winner is the player with the highest cards. After this phase, starts the Chica phase, that is the opposite. The winner is the player with the lowest cards. When the Chica is finished, starts the Pérez phase. This phase only can be played by players with at least 2 cards of the same value. When this phase is finished, the last phase is the Fuego phase, in which one the players has to add all the values of the cards and to get 31 points or more. If any of the players get this 31 or more, starts the last phase, that is the Punto phase or point phase, in which one you have to add the values of your cards and to get a closer value to the 31. During the phases, all the players can bet stones or piedras. To bet, they only have to say envido. That means I bet. And the minimal bet is 2 stones. If you want to do an all-in, you have to say órdago. The match will finish as soon as a team gets the 40 points. There is no limit for the number of games. Okay, it's time to review the architecture of Iris Muz. Iris Muz is based on Docker containers. The first one, Iris Muz, is the instance of InterSystems IRIS. The second one is our local LLM, a Llama local model. Web Gateway is going to be the responsible of the redirection of the request from the front end to our Iris instance. And finally, our front end developed in React. Okay, before to see the Iris Muz in action, let's go to review the code of our project. As you can see here, we have different folders that it's the different Docker containers that we are deploying for the solution. The first one is the IRIS folder with all the code of our IRIS instance. This one has the local model. It's like 4 gigabytes of code. Muz frontend belongs to the React application and the traditional web gateway. All the configuration can be reviewed from the Docker Compose file. Okay, let's see briefly the IRIS code. The most important thing here is the definition of the tools that will be used by the local model. As you can see here, we have defined a very simple tools to help the local model to take decisions. The first one, it's the tool for the discard phase. The local model has to know if the cards that they have received are good cards or bad cards. So we provide our local model with this tool. For the rest of phases, we are providing the hand strength. If we open the code, you can see here that this method gets all the cards received by the player and the phase. It's not the same to have 3 kings in the grande phase than 3 kings in the chica phase. With these tools, our local model can play perfectly to the Muz game. It's time to see our Muz in action. This is the main screen of our web application. As I told before, this application has been created using React. The main screen is a list of the different tournaments created in the game. In our case, we don't have any created yet, so we are going to create a new one. By default, we are creating the different teams and players using our local model. We have defined the prompt, asking to the model for the name of the players using a very traditional Spanish names, the same with the name of the tournament. Now we have defined 4 teams for this tournament, and we create our tournament. As you can see here, we are this one, the human player, and the rest will be managed by the local model. Let's go to create the tournament. And here is our tournament. As you can see, we have the semi-final phase with the 2 matches. Let's go to see a game between 2 computer players. This is the main screen of the game. The first phase, as we told before, it's the discard phase. All the players are deciding if they want to discard or not. This player has cut the Muz because he has a pair of 2 5s, and they are in the grande phase. Depending on the type of the player, he can be a bluffer, conservative, or any kind of that we have defined in the prompt. The decisions will be different. Will be more aggressive, less aggressive. In the chica phase, this player with 3 1s, it's betting. The pair, it's been decided by the different players, as you can see. Yeah, and at any moment we can check what is doing our local model. The actions are answering what the players want to do. He wants to bet, he refused to bet, and all different decisions that we have defined before. This is the final result for this hand, with 3 points for Cofradía del Amarraco and 10s for the Ronda del Alguacil. As soon as the first team achieved the 40 points, the match will be finished. Okay. Now we can see the game with the human player. It's gonna be the same. In this case, we can see the cards of the other players. And in this case, this team has cut the moose. So in theory, he has good cards. In my case, I have no very good cards. I have a pair, a king. In the moose, the 3 is the same that the king, and the 2 is the same that the 1. The 1 is good for the chica face, the 3 is good for the grande, and in this case, this player has bet 2 stones for the grande face. My partners won the bet, so in this case, the bet will be accepted. I will say that I don't want. And we go to the next phase, the chica phase. The first player he doesn't want to bet, and in my case, yes, I want to bet. Just like a bluffing. I am betting 3 stones, and this player has accepted the bet. It's time for the pairs. I have pairs. This one have 2. Let's see what he wants. He's betting 3. Maybe he has good pairs, so I refuse. I don't want to bet. Let's go to the juego phase. I don't have 31, but any of the players had. So you can see here that we have very bad cards. We don't win any point, any stone, and the other player has won 9. Let's see the cards. This is the reason because this player has cut the moose. He has 2 kings. It's a very good game for the grande face. And we don't have any good game. So this is our game. And to finish this session, what do you need to play Iris Moose? Well, it's very easy. You just need to open the OpenExchange webpage, look for Iris Moose, and the first one, it's the game. You only have to follow the instructions that you can find directly from this screen. You will need to download your local model. I suggest you to use the same that I am using here, because right now it's configured to use Llama, but you can try with another one. In this case, it's not uploaded because it's almost 4 gigabytes of code, and this file it's used to make the Llama CPP to understand the use of tools by the local models, because you can find local LLMs that are not working very well with the tools. And that's all for me. Thank you very much for your time, and if you have any question, you can ask me directly using the community developers, writing directly to my account. Thank you very much.
Let's finish with the games and go on to our yes, I know it's very, very sad, but anyway, let's get to our customers and partners who are going to share their projects and their experiences with working with AI Hub. And now I invite Gianni Muzzin to share what he's done. So Gianni, you're very welcome to tell us your experiences.
Okay. Hello, everyone. Can you see my screen? Okay. So I will explain my journey with AI Hub and why we try and why we choose AI Hub. First of all, we have the need to use AI into our software by our top management, and we try a lot of tools like Python with LangChain and so on. but we don't use that because it's very difficult to maintain, very difficult to install with our software. So we discovered the AI Hub at the Ready 2026 with the hackathon, and we were able to play with the AI Hub at the hackathon, and we was it was very easy to play with, to install it, to develop, and so on. So we did the setup. I will skip these phases, and we did a lot of POC. The first one was a DB management with tool and tool set to add, to search, to delete, to do some statistic. I'm sorry, but the prompt is in French. I will not read it, but that was the first POC for us. The second one is an iris monitoring to get the error about iris, to get some information about the code, about CQL, about what we want and what we put into the tools. That was very useful for the support team, for example. And I did a screen to test all our agent into Iris. We can see the configuration about this agent, if we use which provider, and so on. And we can test directly the agent into a front end to ask some question, also in French. I'm sorry, but the first question was how many people into my database. It was 5, and the second one we can see in the screen is, can you add George Weber in my DB? And he asked me for the missing information like ages and mail, and I add the information to add the data into the database without any problems. After that, we choose a real use case to develop into our software to get into production, and we choose a summary agent to get information to the doctor. The purpose of this agent is to time saving into a consultation. So we have 2 agents. One is the medical form summary agent to do some summary about just one forms, and a second one to do a patient record summary agent. There is a technical screen to test. In the left side, you can see we have the context, we have the patient, and we have all medical information. And on the right, we have the structural summary for the patient. I will just display my second agent. Is to the medical report summary. Is used by the first one I display. And after that, we can see in the doctor flow, the workflow of the doctor, the data, then the summary of the patient. You don't have to go in other application or someone else. It's directly into our software and into the workflow to save some times. There is the prompt. It's a long prompt. I will not read it again, but we have to be clear with the prompt. We have to say what we want, what we don't want, but very clearly. You know that when we use a prompt, we have to be very clear about that. So what we work well with the integration AI Hub for us is the native integration into iris, because it's very easy to install, to develop, and so on. We can do very quickly a new module to give to the doctor in production, and we have no extra process like install a Python or server or so on. But we had a lot, some difficulties also, like integrating into our existing processes, because we have a old application, so it was difficult. The first of all is to use Docker. We didn't use Docker before that, so it was a difficulty for us. At the beginning, the documentation was also a difficulty for us, and now we have a new difficulty is to the log and the traces that we can't give us the enough information, but that we can discuss with Benjamin for a while. So what we like about that, it's we don't have a new architecture for using an LLM, no extra installation, all into our script, and real-time saving for the doctor. So to finish, it was easy to start, but we need to go deeper for us into our development, but also with the documentation and the module AI Hub. So thank you, everyone.
Thank you, Gianni. It is especially useful to hear not only what the technology can do, but what people discover when they actually start working with it. And we're continuing with another external perspective. Our next speaker is Heloisa Paiva from Zarmic, and she is going to show us another real-world use case for AI Hub. So, Heloisa, the floor is yours.
Hello, I'm Heloisa. I work at Zarmic, that is revenue cycle management and hospital finance expertise combined with state-of-the-art technology. So what I mean by that is that we started with Roman, who has, I think it's 25 years of experience. He told me the exact time once, but I don't think I got it right. But it's something around that, with revenue cycle management and hospital finance expertise. And he realized that this is a big problem in the US because the lack of technology in that. So we have ongoing technology everywhere, like the AIs are getting so much better every day. Every week we have a lot of improvements we can really follow. So he wanted to combine those words to fix a lot of problems we have there. So one of the things we've all, being on the finance sector, being on the healthcare sectors, we've all faced this situation. So let's say a finance director at a healthcare provider opens a report every month, and the report is here. So, of course, this is fake data. So the report tells what was billed, what was paid, what was refused. All this data is accurate, but she's a finance director. She's not a revenue cycle expert or anything, so she might not know exactly what these reasons are, what all this means. Maybe she asks someone on her team that understands it better to write an interpretation of it, but maybe there's not time. And, well, for the last few months, maybe years, most people are just doing this. But this might not, that is like opening a ChatGPT or a Gemini or whatever. You put the report there and you ask for a summary or to explain that, to understand what that means in your business, in your area. But the chats don't have all the context. The chats don't know specifics about that business or maybe about that hospital that you're seeing the report from. And it will probably provide like a big answer. And as you can see, this scroll bar was this tiny. So this was like a giant answer. And it didn't get to the point that is, okay, I have this information. What do I have to do next? That is what matters for most directors and for most people that are scanning a report, of course. So the obvious thing here was to build a chatbot that has the context for this, but there's a deeper concern to that. That is, we're showing data to a person who has no knowledge of that data. So the person might not know what to ask. So for that, we build a whole narrative. So this is our real environment. We have like all the parts specific for a lot of kinds of users, but this is for finance directors to understand what is going on with the business without having really to know the specific details under it. So the input of this narrative was a table very similar to this one. And now we can really understand. So let me read the first sentence. So this period holds this period right here, of course. It holds a lot of claims carrying this amount under patient responsibility. So the patient needs to pay it. And this was the price charged. And this was the price remitted. So this is easy to understand for everybody that has no knowledge of the healthcare finance sector, which means it can be read by any user. It can be, this is meaningful to everybody in the healthcare area. Everybody can understand that. Everybody can work with that. So the table we had in the beginning now is valuable to the whole healthcare system. And it's that simple. So a big problem we have when we as developers start using AI is that the biggest fear we have is that we don't know what the exact output will be when we are using an AI. So we've been like many years used to writing a very deterministic code, and we're gonna write this code and it's gonna print this, and we're sure this is gonna run okay when we show it to a client. But with the AI, we fear a little bit more because there's all the context. We don't know what we'll receive. So here's how we solve it using the AI Hub. And I'm going to explain why the AI Hub was so important to making this very trustable to put in an application. So before that, I'm just going to say I'm not going to get long on how this costed for me to adopt, because it was really an afternoon from the time I first opened the AI Hub documentation we already have to installing it. I installed it as a second instance. So we had our running IRIS instance with a lot of data, with a lot of ongoing code, giant databases, and I didn't want to migrate all that, so I installed another very simple instance that has AI Hub, and I connected both of them through REST API. So let's say in the end, I decided, oh, I hate it. I'm not going to use it. I was just have to delete it, and everything was still there, and I haven't moved everything, and I would have lost like an afternoon of knowing a new technology. But you're gonna see why that's not how it ended. So we have the narrative here. We have a lot of information going back to our developers' greatest nightmare, that is treating non-deterministic outputs for our code. Here's how we solve it. So a problem that the artificial intelligence comes to solve is that before it was really hard to treat the chaotic data like audio, video, images, and human language. It was really hard to treat that kind of data because it has so much noise, and again, it's not deterministic. So ever since we have AI, we can not only read from it and transform it into data, but we can also produce it. So right here, building a narrative, I had a table, so I had very specific data, and I turned it into prose, a narrative. So how can I validate that in order for it to go to my application? Of course, I can put since AI Hub is very integrated with InterSystems, I think we have a lot of developers here, so we all know that it's very easy to build a path that it needs some kind of human approval to get this narrative to go to our application, to go to our clients. But there's another step to that we added. So I used first the AI Hub as like an outbound. So I have data, I transform it into narrative, but I can use it also as an inbound, because building a new agent on AI Hub is not a new project. It's like a 5-minute few lines of code, as we have just seen with Gabriel. So since I spent like an afternoon building this part, I was like, okay, I have a lot of time to make a validation part of this. So there, I don't need to have a human validating every single narrative for every single client. We have like daily narratives, weekly narratives, so that would be a lot. So how can I make this very trustworthy? I built another agent, again, very quickly, and the agent reads through the narrative and tries to build that table again. So it's really very. I don't know if we have like a maths enthusiastic here. I graduated in math, so this was really fun to me to realize, because every time we have a non-deterministic or non-uniform data, we kind of use methods to transform it into something we can process. So that's what's happened. I had a table, I transformed it into a narrative that is very hard for a computer to read, so it's very hard to validate. So I just used the exact same non-deterministic tool to build again something deterministic. So in the end, I have a table to compare to a table, and there was just a bridge that talks to humans in the middle of it. I don't know if that makes sense. I get a little bit excited and I talk a lot. Sorry. So that's pretty much it. We use the AI Hub as an inbound and as an outbound to make the connection between the raw data and the human being that is using this raw data. And we made it trustworthy by making a validation that can treat human language into a computer language again. So that's how we went from sending like not never ending PDFs with tables like this to having an application that actually talks to the person and says the next steps, suggestions, and all this narrative, of course, is filled with the probably 55 years of expertise of Zarmik. So that's it. That's our case. It was very easy to learn. It was really fun to have such an outstanding output to that. And thank you for the space to share our work here.
Thank you very much, Heloisa, and thank you to all of our speakers. We've covered quite a lot, from the goals behind AI Hub and the technical details, through some fun experiments, and all the way to how it's being used in real-world projects. And before we move on to the next item on our agenda, here is a quick note on where you can continue from here. If you want to keep the conversation going, please join our Discord channel. There you can ask questions, exchange ideas, and discuss use cases with other developers. You can also join and follow the developer community for the latest updates about AI Hub, examples, opportunities, and other information. And if you'd like to try the AI Hub yourself, you can sign up for the Early Access program and start exploring it firsthand. All the QR codes are now on the screen, so feel free to scan any of them. And before we finish, the last thing. If today's demos and use cases have given you any ideas about something you'd like to build yourself, this next part is particularly relevant. Let me introduce the Community Bounty Program idea to application. And now I'd like to explain how it works and how you can get involved. The idea of this program is that every 2 months, we choose several ideas from our portal and ask our members to build small, focused open source applications that implement these ideas and publish the solutions on our Open Exchange platform. As a reward, we're giving people official Credly badges and, of course, Global Masters badges. We're going to promote your applications across the developer ecosystem and social media. And obviously, you're getting Global Masters points, which you can then exchange for tangible gifts and tangible rewards. This round, we have several ideas about the AI Hub. So the first one is to create a generic agent test UI for AI agent. To be more precise, the task here is create a chat interface for the new AI Hub where you can chat to any AI agent class. So you open the UI, select the AI agent class, and start chatting in the knowledge that it has all of the tools, system prompts, skills, etc. that are defined in the agent class. And if you make it multimodal, it will be even a bigger plus. The second task is the MCP Data Exposure Toolkit. So for this, using the AI Hub, we ask you to create samples and DORA templates for discovering and exposing enterprise IRIS data via MCP securely. This could include templates for exposing different data formats, such as globals, SQLs, DocDB, etc., or give different examples to show how agent access to sensitive data can be controlled. And the last one, but of course not least, my first agent, end-to-end starter. For this, we ask you to create a single minimal agent to solve a task using a variety of AI Hub features. For example, skills, tools, external MCP server calls, sub-agents, etc. So all this needs to be neatly packaged into a Docker Compose project. So that's the general idea of our Community Bounty Program idea to application. And that's basically the end of the webinar. Thank you very much, everyone, for joining us and for taking part. I hope we'll see you on our future developer community webinars. But for now, we wish you a good continuation of your day. Goodbye.